to go over something that I did in the first semester that I always do when I do a first semester class, and this is what you should know all the time. I allowed students to use this 3x5 card the whole way until the final. You could not use it on the final, but at least this was burned in your brain by the time you got to the final because you'd seen it 900 times. So this is pretty simple. We're going to put in series rules. And the first and most important rule of series is current is constant. In other words, the same anywhere in a series circuit or a branch, a series branch of a circuit. The current is constant. 2, voltage is additive. The voltage drops equal the voltage supplied to a circuit. Everybody's with that, right? 3, what's left? EIR, resistance is additive. The resistance of each resistor in a circuit is equal to the total resistance of the circuit, assuming you only have resistance. Okay? And then 4, power is additive. So total power dissipated by each branch of a circuit is equal to the total power dissipated. Okay? So that's what your 3x5 card should look like, more or less. There's one more formula that you could have in the lower left-hand corner, but we're not going to do that here. It's a shortcut to find the voltage drop across any one resistor very quickly and easily, and if you have that on your 3x5 card, you can keep it. If you don't have the general voltage divider rule in the lower left-hand corner of your series 3x5 card, don't worry about it. So now we're going to do the flip side of the card. On the back of the card, you're going to write the parallel rules. Parallel rules. And the first and most important rule of parallel is what is constant? Voltage is constant. If you have a supply of 25 volts, you'll have 25 volts across every branch of the parallel circuit. Okay? Okay? And current is the only thing that is additive. So the currents, so that means that parallel circuits are current dividers, right? Let's go back. I want to go back to the first card. Now, we know that series circuits are voltage dividers. You remember that if you've got 3 resistors in series, you'll have a different voltage drop across each one, and you can actually supply things with that. Like in your car, you've got something that plugs into your cigarette lighter, and it's getting 12 volts DC, and you're getting out of it 3 volts for your cell phone, right? How does it do that? It's just got a couple little resistors in it, and it's dividing up the voltage that's supplied and then taking off that parallel from that one resistor that has 3 voltage being dropped across it. Okay, so the third rule actually has 3 parts. In parallel, if you have resistance is all the same. It's all the same. If you have 5 resistors that are 1,000 ohms, they're all the same. You can say that the resistance total is the resistance divided by the number of them. So if you've got 3 250 ohm resistors, what is your total resistance? Very good, 83 and a third ohms. Okay. Now the second rule is called the product over the sum. And the handy part about the product over the sum is if you can say it, you can remember it, number one. And if you've got the simplest calculator in the whole world, where you're fairly good with multiplication and addition and division, that you can do it anywhere with the easiest, but it's only for 2 resistors, right? Product over the sum is, what is a product? That's where you multiply. So R1 times R2, and a sum is where you add things up. R1 plus R2 is equal to RT. So the resistance total is the two resistors multiplied over the two resistors added. Very simple, easy formula to use and remember. Now what can you do if you don't remember the other formulas? If you just want to use product over the sum, can you do three resistors? You sum two, and you get the total resistance of the two, and then put that resistance as a product of two resistors and call it, let's say, R12. And then use 3 as your other resistor. So you could do R12 times R3 over R12 plus R3. Okay? So you could use this for more than one resistor because it's a nice simple method that you can always remember and always use. But you've got to remember how to go about it. Not a big deal. And the third rule, the most difficult one to use probably, but the most functional if you have a calculator that does product over the, if it does reciprocal easily, like the TI-30X2S, it becomes the easiest one to use. It's called the reciprocal rule. And it's, where did I put that line there? Oh, I remember. I know what I was doing. Oh no. That's it. Okay, what's going on here? How come my eraser's not working? Oh, where is it? Hey, like that. Okay, let's get back to doing this. 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over however many you may happen to have. So we're going to call that Rn sub n. So that could be 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4 plus 1 over R5. However many you may have, you just keep adding the reciprocals up, and then to get the resistance total, you take the reciprocal of that. So let's do a practice problem where we have a, let's see, say we have 100 ohm, a 200 ohm, a 400 ohm, and a 500 ohm. So pull out your handy dandy TI-30X2S, hit clear twice, get all the junk out, and we're going to put in, just punch in the number 100. Punch in 100 and find the button that says X to the minus 1. It is right above the number 7. X to the minus 1. Now hit plus. Now put in 200. X to the minus 1. Plus. 400. X to the minus 1. Plus. 500. X to the minus 1. We already added all the ones we up, so just hit equals, and that'll give us the total of all the reciprocals. And that's a number we don't even want to look at. Don't even look at it. Now hit X to minus 1 one more time, and hit equals. And you get 51.2. That's the total resistance of those resistors in parallel. And that is the simple, easy, quick way to find your total resistance in parallel if you happen to have a TI-30X2S. Other calculators will do it in a slightly different way, but this one does it that way. And what do we know about parallel circuits? Anytime you do a parallel problem, the total resistance is always lower than any one single resistor. And parallel circuits are current dividers. If you have 10 amps going through 4 resistors, it's going to divide up that current proportional to the resistance. Actually, it's kind of the inverse of the proportion, but that's a whole different Oprah. Okay, so that is what's on your 3x5 card. Nothing else can be on that card, and I will allow you to use that on a few quizzes for a while. Everybody okay with that? What